Welcome. In this video, we will explore the top 5 database technologies that are most popular and emerging in today's tech landscape. First, let's discuss PostgreSQL. PostgreSQL is an advanced, open-source relational database system known for its reliability and robustness. It is ACID compliant, ensuring data integrity with extensive extensibility. It supports advanced JSON and analytics capabilities, making it versatile for different data types. It also offers high performance and scalability for demanding applications. Here's an example of JSON operations in PostgreSQL. We create a table called products with an ID and a JSON B column for data. Then we insert a product with its name and price. Finally, we select the name of products where the price is greater than 500. Next up is MongoDB. MongoDB is a flexible NoSQL document database designed for modern applications. It uses document-based storage, which allows for storing data in JSON-like documents. It provides horizontal scaling and sharding, which is crucial for handling large data volumes. It excels in real-time analytics and indexing, making it ideal for applications that require fast data access. Here's an example of document operations in MongoDB. A user object is created with properties like name, email, and preferences. This document is then inserted into the user's collection, and a query is performed to find users with the theme preference set to dark. Our third database technology is Redis. Redis is an ultra-fast in-memory data store, perfect for applications requiring speed. It delivers sub-millisecond performance, making it ideal for caching and session management. It supports pub/sub and real-time messaging, useful for building real-time applications. Let's look at key-value operations in Redis. For string operations, we set a key called user:1001 with the value John Doe, and then we retrieve it. For hash operations, we set multiple fields like name and age for the key profile:1001, and then retrieve all fields. For list operations, we push 2 tasks onto a tasks list, and then retrieve the entire list. Now let's explore Elasticsearch. Elasticsearch is a distributed search and analytics engine, designed for speed and scalability. It provides full-text search and filtering capabilities, making it easy to search through large volumes of text data. It excels in real-time analytics and aggregations. It also offers a distributed and scalable architecture, which is crucial for handling large data sets. Here is an example of a search query in Elasticsearch. The query searches for documents where the title matches database, and the price is greater than or equal to 100. It also includes an aggregation to calculate the average price. Finally, we have Apache Cassandra. Apache Cassandra is a highly scalable wide-column database designed for handling large amounts of data. It is distributed and fault-tolerant, making it suitable for mission-critical applications. It offers linear scalability and high availability, ensuring continuous operation. It is well-suited for time series and big data workloads, especially when dealing with IoT data. Here's a SQL Cassandra query language example. A table called sensor data is created to store device ID, timestamp, and temperature. Data is inserted into the table, and then a select query is used to retrieve data based on device ID and timestamp. Let's compare these database technologies. PostgreSQL is a relational database ideal for complex queries, ACID transactions, and enterprise applications. MongoDB is a document database great for content management, mobile applications, and IoT applications. Redis is an in-memory store perfect for caching, session storage, and real-time applications. Elasticsearch is a search engine suited for full-text search, log analytics, and e-commerce search. Cassandra is a wide-column database, which is ideal for time series data, high availability, and global scale applications. When choosing a database, consider your needs carefully. Consider your data structure and the relationships between your data, the performance requirements of your application, and the scalability and availability needs. Start with proven solutions, plan for future growth, and evaluate operational complexity. Each database technology excels in specific scenarios. Choose based on your application's unique requirements rather than trends alone. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.